everyone, and welcome back to Verifiably Random, where we discuss all the exciting developments happening in the Algorand ecosystem. My name is Marc Vanlerberghe, and I'm Head of Strategy and Marketing. So this is exciting because this is the start of Season 4 of Verifiably Random, and it's a very special episode because I am joined today by our CTO, Bruno, and our Senior VP of Protocol Engineering, JJ, and we will discuss everything that you need to know about the new Algorand release 5.0. Welcome, JJ and Bruno.
Thanks for having us. It's been a while.
It's been a while. It's been a couple of months, right? Like I think the last episode was, I think April, if I'm not mistaken, or beginning of May.
Yeah. It's my first appearance as a member of the foundation. Yeah.
Fantastic. I'll keep all the difficult questions for you. So let's get started. So Algorand 5.0. JJ, can you give us the TLDR of this release? What's the headlines? What are the headlines of this release?
Yeah, I think there's 3 headlines. The headline that is maybe the smallest amount of work because we're ready for it, but the biggest headline is that we have native post-quantum accounts now. So we're using Falcon 1024. It's a post-quantum scheme that was available already as a sort of logic sig prototype, but will now become much easier to use because we built it directly into the native framework that we have for signing transactions. Then the second headline, I guess, is AVM improvements that allow for bigger programs, more capable programs. And finally, there's work that is sort of in its infancy in this release, but will probably grow into something bigger and better over time. And that's that we've changed the way we think about fees. So we haven't increased the fees. We haven't changed the fees for existing programs or existing transactions, but we have made it so that transactions can do new things and pay for those new capabilities.
Wonderful. So let's unpack all 3 of them. And let's start maybe on the quantum side. Bruno, native post-quantum accounts. We kind of had a way to do post-quantum accounts already with Logic 6. Like, what is different here and why?
Yes, and we had the LSIGs that give us the same capability, but they are programs and they cost more. And by costing more, it requires us to start more complex flows, to pack the groups with these so-called dummy transactions to pool the fees and have enough budget to do some more interesting things. Being native to the protocol makes it first-class citizen alongside the traditional Edwards-backed accounts, and they will be much cheaper because they don't require complex program to do so. It's much easier to add it to the tooling as well, and very few people check the programs, the design, so nobody has to be an expert in reviewing codes to make sure that they have a proper logic sig that backed Falcon account, so to speak. And this is just our first step. So Falcon, we had experience with Falcon. And the introduction of us being able to do native Falcon accounts also opens the door for us to, in the future, potentially add more schemes. So we want Algorand to be crypto agile in this new world in which there's an emergence of new signature schemes and the quantum threat. And it's hard to see the future. So we want to be agile and add and also be aligned with standardization bodies like NIST, because companies that do have security requirements and some certifications in mind, they might follow along with what NIST says. They might use hardware that has certain signature schemes, not others. So we want to keep the door open so for us to be flexible. With also, as part of our roadmap, as we announced, we have native Falcon accounts now, but we will do the same we did for Falcon with hybrid accounts. So most likely we'll start with also an LSIG version to have an account protected by both schemes, a classical scheme and a lattice-based scheme like Falcon, giving us the best of both worlds for these times that we live on with the uncertainty of Falcon.
It's definitely interesting when you look at the markets overall and the urgency that is definitely increasing with regards to quantum security, right? Like it is more and more becoming clear that the progress that is being made on getting to a production-ready quantum computer is accelerating, right? Like the work that Google has done, the work that IBM is doing, and some of the others are doing. So it seems to me like Q-Day is approaching faster than everybody kind of anticipated. And so you mentioned the roadmap. Maybe Bruno, you can talk a little bit more about that. Like where are we in our roadmap to getting Algorand quantum secure?
Yeah, so it starts with the native Falcon accounts that JJ mentioned. So that's going out. I mean, the protocol has sort of been pushed to be voted to be upgraded, and
Well, it
hopefully
starts with state proofs, right? That was our first step
yes,
in our journey of quantum security.
yes. Since 2022, we had state proofs for securing sort of the ledger state, looking to the past, but we obviously that doesn't change the signature scheme of current accounts and doesn't touch consensus and the VRF. And so that we have as part of our roadmap. So the next step, once we have native Falcon accounts, we'll likely do another version of Falcon that we need for consensus, Falcon 5.12. Eventually, at the end of the year, or beginning next year, we'll have an update on the VRF that Chris Picard is working at the moment. And the step after that will be consensus itself. So we have participation keys and we have these ephemeral one-time keys that we use for voting. And so we'll upgrade those as well into a lattice scheme, in this case, Falcon. And then we can say we're quantum resistant at that point.
And all of that by end of 2027?
That's the goal, yes.
Good. So now that we have native accounts, quantum accounts, like how can people actually use this? Is this like once the protocol, of course, the protocol has to be accepted, has to be voted on, and we'll talk a little bit more about that later. But like once it's live in production, how can people now actually use these post-quantum accounts?
Yeah, so because it's native, unlike an LSIG, it's going to be much easier for us to add to our tooling and to our wallets. So Pera will support the ability for you from the same 25 words that all of us are used to using, derive a Falcon key that then creates a set account. This because we have been in parallel upgrading all our SDKs and AlgoKit. So in a way that our developer tools are ready and it's more streamlined than people having to do LSIGs. So it's going to come a little bit later, but Pera and the SDKs and our tooling will be supporting Falcon as a regular account in Algorand, and people will be able to connect to the apps and sort of do their operations that they're used to do.
Is there any changes required on the app developer side to be able to support Falcon accounts, or?
Yes, so there'll be a little, so with Falcon, so we haven't changed any of the previous transactions and the previous fees for the existing app calls and transfers. But for Falcon, we're introducing resource-based pricing that JJ can speak a little bit more about. That is going to have to, people will have to know if you're using a Falcon account. And that's going to change the fee a little bit. We're working with ecosystem partners like Use Wallet and others to make that as easy as possible.
And so if I'm an institutional party and I have a regular account and I want to move everything to a Falcon account, do I create a new account or can I just rekey?
You'll be able to rekey from day one. So you can if you have a traditional account, you have all your history, your assets there, rekey and we'll give you the protection. We'll change basically your authorization key for that account. And you'll be able to do so, keep the same assets, keep the same history, and it will be quantum resistant at that point.
So what I like about this actually is when you think about this and you compare what we've done here to what many other ecosystems are doing, I think we've thought carefully through the actual implementation of this. It's not just a new feature that we're just creating and throwing over the wall. It's actually something that is production ready, that is ready to be adopted by our ecosystem. There is going to be an SDK, there is going to be the Parallel will upgrade it. So this is a real feature that hopefully will get a lot of use, and people will actually be able to secure their funds as soon as this is live. And as soon as it's voted on, people will actually be able to secure their funds and make them post-quantum resilient, like in the next couple of weeks, which is quite exciting and very different from, the very kind of like vague 5-year roadmaps that we see with many of the other crypto ecosystems.
Yeah, and for those institutions out there that if they're concerned about the quantum threat, Algorand is ready, and we feel we're doing the responsible thing. Maybe some people say, "Oh, you guys are being a bit early." I'll say it's the responsible thing, given that's more likely than not that the quantum threat will come earlier than. If you asked last year, would say it would be a few decades away. It seems it's going to come earlier than that. So for us, is doing the responsible thing, and yeah.
I mean, to me, it's like one of the key things that we always talk about, like, hey, the future of crypto, and be able to kind of get the trillions of dollars of like assets, real world assets, tokenized on chain, and people, and that's ultimately the goal that we all have. But if you put yourself in the shoes of an institution, would you really want to tokenize $1 trillion worth of treasuries on the chain that is not quantum resistant? At this point, you'd have to wonder if this is actually a smart idea. And so I think that's why I think what we're doing here, and Bruno and JJ, what you've been working on, is so important, because it potentially will unlock a much like higher level of tokenization than is possible before. Because if I'm an institution, I'm not tokenizing on a chain that is not quantum resistant or doesn't have any concrete short-term plans to become so. It's just too risky.
Yeah, 100%. And you even see from administrations and countries starting paying attention. So the threat is real. I think that there needs to be offerings out there for people in businesses to know that, have the confidence that their assets are secure in this threat.
Great. Well, let's switch to the second part of this announcement, resource-based pricing. JJ, tell us more. What is resource-based pricing?
Historically on Algorand, every single transaction was charged the exact same amount, pretty small amount, just to prevent spam. Now, the problem with saying every transaction is going to be very, very cheap is now you're sort of locked into making sure that every transaction is a very, very small amount of work, so that you don't have to worry about whether someone's performing a simple pay transaction or a more elaborate app call transaction with a lot of data. And in fact, we didn't allow a lot of data. We always were very careful to make sure that all of our limits were small enough so that one transaction, whichever kind of transaction it was, wouldn't cost the network much more than any other transaction. And so we were comfortable charging one min fee for every single transaction, no matter what it was. Unfortunately, that creates this limitation where in order to get a lot of work done, you need extra dummy transactions. You need to essentially tell the network, well, I want to do even more work than you would normally allow one transaction to do. So I'll put 2 transactions in my transaction group, and now you'll kind of let it slide when I do more work, right? And indeed, that's what we did. So there are a lot of places where, and I think our Falcon LogicSig implementation is a great example of this, where people had to include extra transactions in their group just to be allowed to include the one big transaction that they really wanted, which was the Falcon LogicSig transaction, which requires a fairly large amount of data. It requires a Falcon public key and a Falcon signature. So we're trying to move to a world where if you want to do a little extra work, put a little bit of extra space in your transaction, you pay for a little bit of extra space in your transaction. You don't buy a whole separate transaction that's mostly not doing anything else except giving you extra space, for example. On the other hand, we didn't want to immediately move to a world where, let's say, a transaction with application args, which is fairly normal for an application, but it is extra space, gets charged more than a pay. We didn't want to do that immediately because applications that are already out there sending transactions to the network would suddenly start failing because their transactions would cost more than they're used to. So what we did is we made it so that we loosened the rules, we loosened the limits in several different places. And we said, if you exceed what used to be legal, then you pay per byte of extra space. So for example, notes, it used to be, could only be 1K. Now they can be 4K. But for every byte over 1K, you pay an extremely small amount extra. So, and the point here is that you pay less than you would have to pay if you put a whole nother transaction just to get another K's worth of space. But you do pay for the extra space that you're using. So that's sort of the reasoning behind it, is to let people pay for what they're actually using. And the rule we kept in place for this upgrade in particular is that nothing that used to be legal has a higher price. So the hope here is that we've sort of
So it won't break anything.
That's right. And we put out a carrot instead of a stick. We didn't say, you must, hey, dApps, you have to immediately adapt to this new price now, or else you're going to break. We've instead say, hey, dApps, now you might be able to get things done in a more convenient way by using a single transaction if you pay a little extra for your note or for your larger application args, etc. And so that will teach dApps over time. dApps will adapt, and they'll start asking. The way to find out how much extra to pay is to use a call called simulate, where you first submit the transaction to the network, to your local algo who doesn't submit it to the network, and it just computes how much you ought to pay for that transaction. And so as dApps adapt to this new model where they always ask how much fee should be placed into this group, we might eventually be able to change prices. But that's not my choice. That's the Economic Advisory Council who will make those sorts of decisions. But now we're able to make that kind of choice, so that someday we might say, hey, a pay that has no note and no lease and none of the other little features that are possible, the simplest possible pay, maybe it should be cheaper than an application call that has a fair amount of extra space and is doing a fair amount of computation, where before we tried to keep them all in the same bucket.
So the bottom line is that with resource-based pricing, the way we've implemented it so far, anything that was legal before will continue to be legal and will continue to be charged at the same price. So so that nothing actually breaks. But we've relaxed the limits, and so if you want to go above the previous limits, then you kind of pay on a per resource basis.
Right.
Model.
So dApp makers should now start asking themselves, oh, maybe I can do things in a simpler way now. Now maybe I can pay a few extra micro algos and do everything I needed to do in one transaction instead of in 2 or 3 dummy transactions. Logic SIGs being the PQ accounts being a perfect example of that. So a Falcon signature costs 3 min fees. Which sounds like a lot, except that it used to be, if you wanted to do the logic sig-based mechanism, you needed 4 total transactions to hold all of the data, because, as I mentioned, a Falcon transaction contains a lot of data. So in a sense, it used to cost you 4 min fees to perform a Falcon transaction. You did it by issuing 4 transactions. And now you issue a single transaction that costs a little bit less than that 4, but does a lot more work than our normal transaction, so it's charged accordingly.
Yeah. And so if you're a developer, you do have to now start thinking about this new model, right? Because it used to be very simple. All, transactions cost the same. Now with transactions possibly costing different amounts. So developers have to start adjusting to that, and there needs to be a mechanism for developers to find out what a transaction will actually cost, so that they can then include the right amount of fees into the system, no?
Right. And the truth is, developers of complicated applications had to do this already to some extent. So let's suppose I wrote a complicated dApp that executed a dynamic number of inner transactions in order to obtain more opcode budget. Because again, we used to make it so that you had to issue a whole transaction in order to get a little extra opcode budget. So a dApp maker in that world already had to call simulate. They would run simulate, then they would get back a result, then they would count up the number of transactions, including inners, that ended up being executed, and then they would pack a fee, which was min fee times that number. So complicated dApps were already calling simulate and then doing a little bit of complicated diving around in the result to figure out what they should send. Now, because this is something everyone's going to have to do, and it's going to be much more fine-grained, the simulate result now contains something we call usage. It reports the entire usage of your group. So it adds up. Usually it's approximately 1 per transaction, but it might be 1.02 for a transaction with a large note or something like that. And so they will still be calling simulate, but now they'll just be using a very direct result of simulate, multiplying that by the min fee, and that's how much they should include in their transaction group.
So now if you think forward, like one of the big initiatives that is in our roadmap that we've been working on is the whole projecting safety, with the thinking being that at the end of the day, the Algorand blockchain has to become more sustainable. It is currently not sustainable because the staking rewards are being paid out by the foundation treasury. So over time, that's not very sustainable. So So King Safety tries to look at that future and say, like, how do we become more sustainable? What do we do with fees? What do we do with potentially native algo and the cap on algos? And so King Safety is looking at all of these different things and saying, like, how do we build something that guarantees long-term sustainability? So resource-based pricing could be an element in that strategy, right? Because it provides us more flexibility on how we price things. And you could initially price transactions based on resources used, but you could use other mechanisms too, right? We have the
Right.
flexibility now in a later stage to say we'll increase the fees on these transactions, but not on these types of transactions. Is that right?
That's right. And so I think it can help in two ways, one of which I get to try to work on, and the other one, it's other people's job to figure out. And what you've talked about is what it's other people's job to figure out whether we should. It allows people to make the decision, whether it's the EAC or the network as a whole, to change fees on, let's say, maybe application calls should be cost twice as much as pays or something like that. All of those decisions can now be made if we want to, because now we have this concept that different transactions can cost different amounts based on what that transaction is doing. Then the other reason why I think that the part that I can sort of impact is I can make it easier to develop complicated applications on Algorand. If you can develop complicated applications on Algorand, then presumably you'll also pay for performing those complicated operations, and more fees will come in. So I'm sort of seeing it as we created the flexibility for other people to make some decisions, and then we also now allow more interesting stuff to happen. And that interesting stuff will also get charged for doing those interesting things.
Great. How about congestion fees? Is there anything that changes there?
So Algorand has a strange congestion model. We're a very fast chain. And so we have, as far as I'm aware, never actually invoked our congestion control in real life, possibly during some load tests. But the possibility remains that the blocks could be filled by so many transactions that there's not enough room. And so what's the right thing to do in that case? It's to raise fees. Today, we raise fees locally. AlgoD will simply not take your transactions. And I don't mean pack them into a block. I mean, they won't even take your transactions and hold on to them unless if AlgoD notices that it's currently got a long queue, it won't add things to the queue unless they pay extra. But that's a local decision. I mean, it's not something that can be enforced in actual transaction processing. What we've done is we've introduced the idea of on-chain congestion monitoring. So now we will watch the chain and say, every time a block is half filled, we'll consider ourselves to be somewhat congested. And if we continue to be at least half filled or more, we'll consider ourselves to be more and more congested. Someday, I presume, the choice will be made to enforce that during a transaction evaluation. Because if we ever actually are that full, it makes sense the transaction should have to pay a bit more. We're not enforcing that in this upgrade because, again, the rule for this upgrade is nothing immediately breaks. You should get used to the idea of dynamic pricing, but nothing breaks for now. So someday, it's likely, for the same reason that you will ask AlgoD, what should I pay for this group because it's using some wacky features, I don't know exactly how much they cost, please tell me. You'll also be asking AlgoD, how congested is the network? And therefore, how much extra do I have to put in because the network is congested? Again, I expect it won't be congested very often. We're a very fast chain, but the proper infrastructure will be there for making those kinds of decisions.
Great. Okay, let's move to the third topic. You mentioned at the beginning three big things changed. One is resource-based pricing, quantum is the second one, and then AVM upgrade. What about the AVM upgrade?
Yeah, so the AVM upgrade is this. So before I was saying that the way I'm approaching King Safety is I'm trying to make the AVM more useful so that more things can be built on it. And I think we've done a few things in this upgrade that will make it possible to make more and more interesting dApps. One is simply we allow larger applications than we used to allow. So again, Algorand's sort of a history was based on the idea of each transaction does a tiny bit of work, so therefore we don't have to worry about accounting for what it does. It does such a small amount of work. Some net transactions do slightly different work, but it's all such a small amount, we don't have to account for it. Now that we have accounting systems in place, we just talked about fees, but we had already introduced an accounting mechanism called using box references for for I/O, for allowing for large pieces of state on chain. With those two things in place, we can now say, sure, go ahead and make a large transaction. When you create the make a large app on chain, not dApp. dApp is the off. I use dApp to mean the off-chain portion of an app, and app is the Algorand technical term for the bytecode that sits on chain. Now we say, go ahead, use a lot of bytecode, because two things will happen. One is, when you create such a large program, you'll be sending a large transaction. You have to send us the bytecode. So now you'll pay for it. If you send a very, very large transaction, you should pay for that extra block space. So you'll pay a little bit extra per byte. That gets the app created. And now when you invoke it, we use the same mechanism that we used for accessing a large box. Now you're accessing a large program. You have to dedicate some of what we call your references, which are, it's sort of your quota for I/O, to execute the application. So the point here is, you want to build large applications, go ahead and do it. Now there is a straightforward way to pay for the extra load usage that you're putting onto the network. And so we allow larger applications, which already is nice. But then another thing that we do in this upgrade is that we've changed our box model a little bit. So I keep using the word box. That's the name for an app's state. You put things into boxes. Large boxes require a little bit more I/O to get at. But what made boxes frustrating for some dApp developers is that, exactly because they were large, they're hard to communicate between two apps. So apps can call other apps on Algorand, an inter application call, but they can only return a little bit of data. So it was hard to store a lot of state on chain and have one app be in charge of that data and hand it out to other apps on demand. So what we've done is we've introduced two ways that boxes can be, if an app wants it, can be exposed to other apps. So on the one hand, there's a simple Boolean flag that an app can turn on that can say, I want other apps to simply be able to inspect my boxes. They don't have to ask me, make an inter-app call to me, which all, by the way, costs money, costs fees. Don't make an inter-app call to me to tell me just to read boxes of my state. Everybody's welcome to look at my state, which is actually a pretty normal thing. So global variables in Algorand, for example, you can read another app's global variables because it's a safe thing to do. You can't touch them, but you can read them. And so boxes, we didn't originally introduce that way, but now we're giving out apps the opportunity to decide whether they want to keep their inner state hidden from other apps or to allow it to be readable. So reading other apps' state is pretty much always safe. But the other thing that you want to be able to do is you want to be able to allow, if even our more generous apps are still not big enough for you, you might want to spread your computation across several different apps. But if they're all accessing the same state, previously you're kind of out of luck. All the boxes would be in one app. Now we allow that app to expose their boxes, not just for reading, but also for writing to a protected set of sort of related apps that we call family apps. So if they have the same creator and you turn on this flag, then they can access your boxes, not just for reading, but also for writing. So now you've got this shared state with a set of cooperating apps that can read and write that state. And I think together, those things are going to allow essentially arbitrarily large and complex applications. I don't want to get caught saying 16K is enough forever, but by having 16K in different apps, each of which does its own job, but all accesses the same state, you can do a lot of work.
Wonderful, wonderful. So, okay, so we've basically covered pretty much everything that is new in this upgrade. So let's talk about the process of getting this live. Bruno, what does it take? So we pushed it out. What does that mean? Is it running on the nodes? It's not, right? So it needs to go to some approval process. Can you talk a little bit more about that?
So the new release is version 5. So it's a major release. It has been published yesterday, and it's going through the rounds on the network, so people can upgrade. So for the changes to go live, we need to meet 90% threshold. So people have to upgrade their nodes. Once we meet that threshold and the voting window finishes, that triggers the features to go live in about a week's time after that. So once we hit the 90% threshold and the voting window finalizes, then we'll know a specific time, day where the changes will go live.
Testnet, by the way, has gone through the upgrade, and so now you can figure out the testnet time. It's about 6 days away from now. It will go into effect. So
That's great. So if you're a node runner, go upgrade your node, and by upgrading your node, you automatically vote for the new software.
V5 version 5.
Version 5, big deal. So JJ, any sneak peeks on what's coming next?
Well, I've sort of implied that I suspect that we will one day have even more things payable in pieces, in piecemeal. So, for example, being able to buy extra opcode budget simply by putting a flag in your transaction that says, "I need extra opcode ticks, so charge me a little extra, but then give me more opcode ticks," instead of what we do today is we force the creation of dummy transactions. The same thing might happen for those IO references that I talked about. And the thing that I am most interested in doing, because I think it solves just an absolute ton of application complexity, is allowing a new way to specify the fee that a transaction pays. You can today a fee is absolutely unequivocally paid. If you put fee 50 microalgos, you're going to pay 50 microalgos exactly. I would like there to be a fee that you can set to be higher, that is only used if indeed the usage of your transactions requires it. So you could put a 2 algo fee on your transaction just to not worry about how much work it has to do, and there will be accounting done during evaluation, and most of those 2 algos will not be taken from the sending account. That I think is the biggest thing that I think needs to be done to ease developer burden. So that's what I'm working on next.
Wonderful. Okay, well, this was great. So thanks so much for joining the call. And so next up, we're going to turn it over to Fred, who will give us an update on everything that's going on in DeFi land and with our broader ecosystem. But first, I want to ask Fred a question, which is, has he already upgraded his Reti pool to Algorand 5.0? That's what I want to know. Welcome, Fred, and tell me all there is to know about the ecosystem.
Hey, Mark, it is a pleasure to be back in a whole new season of Verifiably Random. And yeah, man, of course, Fred Estante at Algorand pool has already been running the latest version of the protocol since pretty much the very beginning. And, I had to check earlier today Marc VL's pool, and I'm glad to see you're also running the latest version of the protocol. However, Mark, I had to scroll down quite a bit to find your pool in the list. So if you need any help, getting more stake delegated to your pool, just ping me, okay? You have my number. All right. Well, Algo fam, I am super excited to be back. And of course, our ecosystem doesn't stop. I prepared a few notes on some of the top ecosystem highlights from the last 14 days or so. So buckle up. Our friends at Alpha Arcade reached $260 million of volume in 2026. And they also just opened the waitlist for a perp dex they are building on Algorand. Really cool stuff. And talking about perp dexes, O-Trade also launched the People's Exchange perp dex on testnet. They're gearing up for a mainnet release in the short term, so stay tuned and play around in the testnet. Compex Labs launched the Brownie bot to autonomously manage the community treasure on-chain. Really fun stuff. Emirates Airlines partnered with Crypto.com for payment infrastructure, and that means you can now use your algos to book reservations on Emirates Airlines. Lofty AI integrated Apple Pay into their platform to make it a lot easier to onboard and transact on their platform. And they also just launched automatic relending in the platform just to make the entire operation investment lifecycle a lot easier. Really cool stuff. Our friends from Gonalgo launched Gonna Fight, a really fun fighting game with lots of prizes. You should definitely check it out. Parallel Wallet has been on fire. They released so much in the last couple weeks, it's crazy. They released version 7.0 as a major overhaul, so make sure to update your app ASAP and try it out. They also released ParaConnect v1.6 that allows multi-network wallet connections and sign in with Algorand. Really cool stuff for the developers and obviously the users out there. And they also launched shared accounts with native multisig. That's an incredible feature of the Algorand protocol, and now you can do this with shared accounts. Really, really cool stuff. Our friends at Go Plausible also do not stop shipping, and just released universal receipts for agentic platforms on Algorand to make it easier to track what your agents are doing out there in the wild. And the friends from Transaction Lab released Use Wallet v5 with lots and lots of excellent updates for the developers and ecosystem builders at large. These are some of the highlights from the last few days. As I said, there's a lot happening in our ecosystem every day, and I'm super happy that Verifiably Random is back, so the Algo fam gets to see everything that's happening pretty much in real time. So Marc, that's all that I have prepared for today. Super happy to be back and cannot wait for the next episode. Back to you.
Wonderful. Thanks, Fred. So that's all for now. See you soon for another exciting update. We have a couple of episodes planned in the next couple of weeks that I think are going to be quite interesting. We're going to do one episode on governance. And so we'll have Simon here to talk about that. And I think we're also pretty close to launching something new in the agentic commerce field. And we'll do a dedicated episode about that as well. So stay tuned. A lot of exciting updates to come.